Hi to everyone. MEM School of Engineering, Department of Mechanical Engineering, online classes, subject mechatronics, semester 7. So myself Saravanan, Assistant Professor in Mechatronics. Uh, Today we are going to see about the data handling in the PLC. Okay, in unit number 4. That is the um, fourth chapter of PLC. So in this concept, we are going to discuss about timers, counters, individual internal relays like that. We are going to discuss. Okay. So timers, counters, individual internal relays concerned with the handling of individual bits. So single on-off signals. Example for data handling: data movement, data comparison, arithmetic operation, and code conversion. These are the data handling process. Normally, in microprocessor, we discussed about data transfer, like data transfer instruction, arithmetic instruction, like that. We discussed. So same here. How they handle in the PLC. Okay, like the data movement, data comparison, arithmetic, and code conversions. So data movement, that is move S comma D. So S is source address, D is destination address. So used to move data from one address to another. So when an input given in the rug, move occurs from the designated source address, source address to the designated destination address. Used to move preset value to the timer, counter from timer or counter to the register. So data comparison used to compare two data values from two different address. So when the data comparison instruction is activated, so compare the data from source address to the data in destination address. If true output is activated or false output is deactivated. So it is used to compare a digital value read from some input device with a second value contained in a register. So data conversion, BC to binary, binary to BC conversion. That is when the data conversion instruction is activated. So convert the data source address to the destination address. The input might be for a thumb fill, switch, or a output to the decimal display. Arithmetic operation. Okay, here we are using register, two register, that is AU and AG for input and R for result. That is addition, subtraction, multiplication, division. When the arithmetic operation instruction is activated, does the operation from different address and store in the third address. Okay, that is AU and AG having the different address, then R having the different address values. Okay, that the instruction. If add means add, subtract means subtract instruction will be used. These are the different instruction sets available in the PLC. Let's see one by one. That is LD, that is load operand into result register. So that is LDI, load negative operand to the result register, then AND, Boolean AND, ANA, Boolean AND with a negative operand, or Boolean or RI, Boolean R with a negative operand. So there are several types of functional blocks in ladder programming that implement logical operations, math operations, then timers and counters. So on delay timer, off delay timer, pulse timer. So on delay timer, that is input. So timer operation, yeah, IN means timer operation condition. PT means preset time, output Q timer output, then ET means elapsed time. What is the maximum time? It will be different. This is the function of on delay timer. So when the input changes from 0 to 1, the output Q changes from 0 to 1 after a time interval set at a preset time. Okay, during the interval, ET output the elapsed time. In 0, before ET reaches the preset time, the elapsed time becomes 0. In 0 after Q is 1, Q will be 0. So develop the ladder logic that will turn on and output light 5 seconds after switch A as the turned on. This is the example 2 for Siemens half delay timer example. There is a pulse timer condition. So counters. So PLC counter instructions keep track of event as it is count. A counter instruction compares an accumulated counter value to a preset value to determine when the desired count has the reached. Counters can be used to start an operation when a counter is reached or to prevent an operation from occurring until a count has been reached. So type of counters in PLC, up counter, down counter, and up down counter. This is the example for up counter. That is input having 3 inputs and 2 output. That is CU means up count pulse input, R means reset input, PV preset value, output Q, counter output, and CVS current value. So these are used for count the step sequence of the input. Down counter, the down counter starts its count from a value PV. PV is loaded to CV using the input LED. Each time a positive edge occurs on CD countdown, terminal the CV is determined by 1. If CV less than or is equal to 0, then Q will be some values. Sub down counter CTUD. So every positive edge on CU increment CV by 1. So every positive edge on CD decrement CV by 1. A counter might be used to keep track of the items in your inventory storage area. Okay, thank you.